Okay, so we are now at the point where we are comfortable to load in data from a variety of data sources into Alteryx. Whether that be data from a file such as an Excel file or a text file, or data directly being pulled in from a database such as a MySQL database, or even data we manually put into a workflow via a text input tool. We have learned how to connect to different files, and all we need to do is simply provide input into some configuration options depending on the file type, and our data will be pulled into Alteryx accordingly. We can now feed this data into subsequent processes. But before we start to perform calculations on the data, or conduct some statistical analysis of some kind, we first have to make sure that the data we are using is in a user-friendly format and ready to be used. Now, unfortunately, we do not live in a perfect world, so we have to be mindful that there could be some cleaning up required to get the data into a state fit enough to be used. This is where the data preparation tools come into play, and they are great for helping us clean up some of the data quality issues we may face when looking at the raw data inputs. The first preparation tool we're going to observe is the data cleansing tool, which helps us clean up some of these data quality issues. For example, we may have some white space that appears before or after a specific word that makes joining this data with other tables tricky. Or we may have some columns of data that contain letters and numbers within a product code, but it's only the letters that we need from the code. These issues can be quickly resolved by utilizing the data cleansing tool, so let's see it in action. First things first, we need to input some data. So let's bring in a text input tool, and we will then import some data that I've pre-populated into the tool from a file called data cleansing. Now I've attached this file in the resources section if you want to follow along with a set of data which incorporates some data quality issues, but feel free to create your own. Now if we observe this dataset, you can see that we have a column called trailing underscore spaces, which, as the name suggests, is a column containing values followed by some white space. So you can see that John has a couple of spaces after it, and Julie has one space after it. Now simply observing this would be impossible to tell that there is white space following these names, but without removing this white space, it could cause subsequent issues in our process if we utilize these fields in, say, any join conditions later in the workflow. So it's important we clean up this data as much as possible before we progress. Next we have a column called leading underscore trailing, which have last names in the column, but this time with spaces before and after the name Smith and before the name Gill. Next we have a column called punctuation, which simply has an adjective with some punctuation afterwards. Next we have a column called salary, which is 10,000 for John, and I will make Julie's salary an empty cell in the text input, which can simply be translated to mean a null value. Next we have a column called cost, which we can see is in thousands, but the cost has a suffix of the letter K afterwards, which will cause issues if we need to use this field in any calculations. Now this is because the letter K will actually make this field a string data type, but we will cover data types in more detail shortly. Next we have a field called comment, which is a little comment about the performance of each person, and we end with a code which starts with a series of numbers followed by a series of letters and then ends with some numbers. Now this may be exactly how we want the code to be viewed, but we will see an example shortly of how we can remove unwanted characters utilizing the data cleanse tool if required. So before performing any data cleansing, let's add a browse tool after the text input tool to see what the profile view is telling us about the data. Okay, so firstly, the trailing spaces column is apparently 100% not okay. Now this should raise alarm bells, and we should certainly look to address the data quality issue we see here. If we look more closely, we can see that we have two values with trailing white space. And if we hover over the valid values within the trailing spaces column, Alteryx feeds back to us that this cell has trailing spaces, so we can also see directly from the results window what the issue is. The leading underscore trailing column is also 100% not okay, and we can see in the profile view that we have two values with leading white space, i.e. white space before the names, as well as one field with trailing white space. And if we hover over the values in the results window, we can also see that Smith is the value which has leading and trailing white space, and Gill is the value that has leading spaces. The punctuation field is coming through as OK, as it has no white spaces and simply includes some punctuation characters after the word, which we can keep or remove if we so decide. The salary column is coming through as 50% OK and 50% as null. And if we look in the profile view, we can see that we do indeed have one row which has a null value in it, so we can decide how to treat this shortly. The cost column is coming through as 100% OK, but if you look carefully, you can see that the field is being treated as a field with a data type of string. This is something we may want to address if we plan on using the number in any calculation further down the line. So despite Alteryx telling us that the column is 100% OK, this is purely from a population standpoint, and there could still be some issue with the respective data types and values within the column. The comments field is 100% OK and is simply a string field with some text in each row, so no complaints here. And finally we have the code column, which contains numbers and letters. Okay, so let's see the power of Alteryx to help us in cleaning this dataset from its current state into a more user-friendly input. To do this, we can simply drag a data cleansing tool onto the canvas and join it to the text input tool. So the text input tool's output anchor will be joined to the data cleansing tool's input anchor. And as you can see here, a single tool can feed its data and data structure into multiple input anchors of different tools, which can result in the data being used in different branches performing different operations, which is great for scalability. Okay, so if we look across to the configuration options of the data cleansing tool, you can see we're presented with a table at the top, which asks us to select fields from the data that is feeding into the input anchor that we want to cleanse. Now we're able to pick and choose by using the checkboxes, but one piece of advice is to start with performing cleansing actions across all fields. If there are specific columns that require a slightly different cleansing option, we can chain another data cleansing tool afterwards to address that requirement, which I will showcase to you shortly. So in this example, we will start by cleansing all the fields simultaneously. Underneath the field selection box, we have the actions we would like to perform. Firstly, we have the treatment of null values. So if we select the replace with blanks for string fields, null values will be replaced with blank cells. And if we were to select the replace with 0 for numeric fields, nulls become 0. Now you may be asking yourself, what impact will this have on my data? Well, let's say you were wanting to perform an average calculation on the salary column across the entire dataset. If you replace nulls with 0, your average will be 5, as the calculation would divide 10 by 2 rows of data, because it recognises 0 as a valid number. Whereas if you had left them as null, the average calculation ignores null values and would have brought back a result of 10, which is 10 divided by the one row with a valid value in it. So deciding on how you treat nulls is obviously important if you're planning on using them fields later in calculations. So keep this in mind, as depending on what the column represents may warrant a slightly different treatment. The next section deals with removing unwanted characters, including items such as leading and trailing whitespace. So to start with, rather than selecting all items initially, let's just leave the data cleansing tool to replace nulls with blanks and 0 for string and numeric values, and then remove the leading and trailing whitespaces, which we know are present in the first two columns. We will quickly add a browse tool to the data cleansing tool and run the workflow. Okay, so if we now look into the results window as well as the profile pane, we can see that the trailing spaces column no longer contains any issue, and it's 100% okay. We can see that there are 0 values with trailing whitespace, so the data cleansing tool has removed it as per expectation. We can also see that this is the case for the leading_trailing column. The punctuation column has not been affected by the cleansing tool, but we can see that the salary column is now 100% okay. This is because the null value that we once saw for row 2 has been updated to state 0, which is considered as a valid value and hence is no longer being flagged as a data quality issue. The final 3 columns have been unaffected by the current run of the data cleansing tool. So with one simple tool, we've gone from having an input data source that looked like this to now looking a lot cleaner. But let's see what some of the other options do so you can observe the result and apply it to any future use case you may have. So firstly, we'll take a look at the all whitespace option. What will this do? Well, removing all whitespace will impact words that are also separated by a space. So if I select this option and rerun the workflow, you can see that the comment column has now changed and the sentence has come through as one long word with all white spaces removed. This is not what we want in this example, so let's deselect this. The next option will remove all letters from the selected columns. So selecting this and rerunning this workflow will actually give us very little output, seeing as most of our columns are populated with letters. But you can see, for example, in the code column that the letters have been removed, which were once upon a time in between the numbers, but we are now left with just the numbers of the code. You can also see in the cost column that the suffix of k has been removed, which means it only contains numbers and can therefore be changed into a numeric data type for onward consumption. If I remove numbers as well as punctuation and rerun the workflow, unsurprisingly, it's removing them every time they are observed in any of the columns we have selected above, i.e. all of them. So the code column no longer has numbers. We have lost the cost, but the k remains, and in the punctuation column, we are only left with the adjective and no punctuation mark itself. Finally, we have the ability to modify the case of the strings. Now there are three casing options. We can change everything to uppercase, we can change everything to lowercase, and we can change everything to title case. So uppercase will change everything into a capital letter. Lowercase will turn everything into a lowercase letter. And title case will change every first character of the word to an uppercase letter. Now note here that the first letters of the code column are not changed, as the original word started with a number which we are removing as per our current configuration options. So the letter A and D are not considered as the first characters of the valid value. But for now, we'll turn off the modify case options as well as the removal of numbers. At this stage, we can rerun the workflow as it completes the first part of the cleansing we want to perform. However, there are a couple of other cleansing operations I would like to perform on this data which do not relate to all columns. So in order to do this, I will drag another data cleansing tool onto the canvas and make sure the output anchor of the first data cleansing tool goes into the input anchor of the second data cleansing tool. Now what I would like to do is address the suffix of k in the cost column. To do this, I need to select the cost column only and then state that I would like the letters to be removed. Now in this example, we do not have any null values, so leaving the replace null option selected is not going to make any difference. When we add a browse tool to the data cleansing tool and then run the workflow, we can see that we get our dataset with the white space removed from all columns as per the first data cleansing tool, which feeds its results into the second data cleansing tool where the k is then removed. You should still note here that the field is treated as a string data type, so we'll need to address this at some point, but this will be covered in the next couple of videos. Now the last thing I want to do is address the final code column, where I want to simply remove the numbers. To do this, I will once again drag another data cleansing tool onto the canvas and connect it to the output anchor of the prior data cleansing tool. We can then select the code column and then select the numbers option from the remove unwanted characters section. We will then add a browse tool and run the workflow. And at this stage, I feel happy with the current format of the table, and the data cleansing tool has done everything it can to address some of the data quality issues that we previously observed. Now, one thing I want to quickly draw your attention to is the metadata of the data that feeds from the output anchor of the final data cleansing tool. Here you can see we have the type of each field, with only the salary column being described as a numeric field, in this case an int16 data type. We will need to change this at some point, as we also know the cost column is a column which holds numeric values. Next to the type, we can see the size of the column, which simply refers to how much space is taken up in memory when working with this data. Now, being mindful of the size is important, as when it comes to working with large data sets, it can improve the efficiency of the workflow dramatically and make things quicker to run. And we will see a very nice tool which helps us optimize the size and type shortly. So in summary, we've taken in a raw dataset which once had numerous data quality issues, as well as fields that needed cleansing in one way or another. We have passed that data through data cleansing tools to arrive at a set of data that is ready to be consumed by subsequent tools. Remember, if required, you can chain multiple data cleansing tools together to achieve your desired result. But it's always best practice to try and get upstream data sources corrected at source rather than having to correct data quality issues through a workflow tool. Now that being said, sometimes the investment to get upstream data sources corrected is far more expensive. So utilising the data cleansing capabilities of a workflow tool like Alteryx can certainly save a significant amount of time and resources.